Okay, so just as a reminder, we have two definitions here that we're going to discuss today. We have our standard position. So if this is our initial arm and this is our terminal arm, we are looking at this angle to be standard position, and it goes in a counterclockwise direction. And we know that directionality by the way in which we draw our arrow. The reference angle is always going to be the small acute angle, and I call it beta, the beta angle, but in my mind I think it's like the baby beta angle. It's always the itty bitty small one that's acute, and it's a cute beta angle. Get it? Should I say the joke again? It's a cute beta angle. Okay, I'm so glad this is being recorded. Okay, so next year your teacher might not call it the beta angle. I call it the beta angle just because I feel like it helps me remember that it is the little reference angle that brings our terminal arm down to the x-axis. Okay, so depending on which quadrant you are in, your beta angle will be different. So in quadrant number 1, I am my own reference angle, which means that your standard position theta and your beta angle are the same. In quadrant number 2, this is your standard position angle theta. Your baby beta angle is to the x-axis. Now, sometimes students make the mistake and they think it's to the y-axis. That's not correct. It is always down to the x-axis. So in this case, we do 180 degrees minus beta. In this quadrant number 3, our big angle is theta, and our beta angle is actually within theta. So here, some people again will think, oh, maybe this is beta. It's a little cute angle. No. We always go to the x-axis. So this is our beta angle. So theta will always be 180 degrees plus the beta angle. And then lastly, if this whole angle is theta, this little baby angle is beta. So that would be, theta would be equal to 360, which is a full circle, minus beta. Okay? So given each reference angle and quadrant number, determine the angle in standard position. So we're in quadrant number 2, which is this quadrant here. We are going to look at 30 degrees, which means that our beta angle is 30 degrees. So this angle here is theta. How do I calculate theta? Theta would be equal to 180 degrees minus beta, which in this case is 30 degrees. So theta is going to be equal to 150 degrees.
Do you put an arrow on that line?
On this line, yep, you can. But you definitely need to put an arrow to show directionality on theta. Yep, who's there? Can I repeat it? Sure. So I look at quadrant number 2, and I draw my angle in quadrant number 2. I can see that my reference angle beta is 30 degrees. The angle between my terminal arm and the x-axis is my baby beta. So my beta angle I write in is 30 degrees. So how do I find out theta? I do 180 minus this little piece, and that's how I get the remainder. So that's what I've done. 180 minus beta minus 30 is a 150. Okay? So this next question, quadrant number 3, same angle. So now I'm in the third quadrant. I'm going to draw an angle. Where is beta? Is it going to be here, position 1, or here, position 2? 2. Good. So this is my theta. This is my beta, and that's 30 degrees. Okay? Can someone tell me, how do I find out angle theta. What math am I going to do? Hurry up. Yeah, plus beta, right? Because I want the straight line plus this little acute angle. So theta is going to be equal to 210 degrees. Okay, now we're in quadrant number 4. So I'm drawing my angle in quadrant number 4. So where is my theta? Is this my theta? No. That's my beta. So my theta goes all the way around. Kind of looks like Pac-Man a little. And then this is beta. Can someone tell us the math that we're going to use to determine theta? Khaled. Say that louder, please. Minus beta, which in this case is 360 degrees minus 30 degrees. So theta is equal to 330 degrees. Okay, try these next 3 on your own, please. Okay, so here we're in quadrant 2. I'm going to just do this a little bit faster. So this is beta. This is my angle. And what did you get for theta? Aish, what did you get? Louder? 120 degrees. Do we all agree? Okay, and this is going to be 180 degrees minus beta. Okay, quadrant number 3. This is our beta, which is 60 degrees. Here is my theta. And let's have Umar. What did you get for theta? No? Okay. Uzair, what did you get? You haven't done it yet? Yeah. Like the arrow? Yeah. Nuha? So tell me what you did. Did you add or subtract beta? Good. And so you're going to add 60 to 180. And what did you get, Nuha? Good. And then Khaled, you're going to do the next one. Can you tell me the math you did? Good. 360 degrees minus beta, which is equal to 300 degrees. Who got all 3? Excellent. Okay, let's flip the page. Yes. Guys, show me thumbs. How are we feeling about this section so far? Different, brand new, but okay? Okay. Personally, I like to go through every little detail of this. This is one section that I've broken up into many different parts. And again, save this note if you decide to take grade 12 advanced functions, because a lot of this stuff you're not going to get in the book or taught depending on which teacher you have. And I find that, again, using the unit circle is really, really helpful for this stuff, okay? So we're going to take another step. So a reference angle can be used to determine trig angles in other standard positions. So this is actually what we did yesterday, okay? So here, R is a reflection of P. So here is my point P. R is a reflection of P. If I take S, S can also be a reflection of P in the y-axis and then the x-axis. And then T is a reflection of P in the x-axis. So this is my beta, but this angle is also equivalent, and this angle is also equivalent. So technically, and this last one, technically I have all 4 of these reference angles that are the same, that relate to my terminal arm, And that's what I can use in order to find out the angles in all of the other quadrants. Okay, so again, we're taking what we know of quadrant number 1 and we're utilizing that in the rest of the quadrants. So let's say you have reference angle. Do you guys want to do 35? Oh no, sorry. What is my angle? What does it say there? 45. So my reference angle beta is 45 degrees. So that means, what is my point P if my angle is 45? What's cos 45? Root 2 over 2. So in the first quadrant, both are positive. Okay? The angle in standard position is 45 degrees. Oops, I made a mistake here. The coordinate point on the unit circle, this is root 2 over 2. This is incorrect. Kala, did I ever get my eraser back? Yeah. I'm missing a bunch of erasers. Okay. So my reference angle here is 45 degrees. So we know this already in quadrant 1. Root 2 over 2. Sine 45 is root 2 over 2. What's tan 45? Good. Now, let's look back at our unit circle. What will our reference angle be? It's still 45 degrees. What is the standard position theta? It's going to be 180 degrees minus beta, which in this case is 45 degrees. So what is my theta? What is it, guys? 135 degrees. What will my coordinate point be? Maria? Right. And look up here, I already put down what the signs of your coordinate points should be. Remember, quadrant 2 will always be negative positive. So cos 135 is negative root 2 over 2. Sine 135 is positive root 2 over 2. What is tan root 2 over, what is tan 135? Negative 1. Okay, quadrant number 3, S is going to be 45 beta angle. How am I going to calculate theta? It's going to be 180 degrees what? Plus, good. Plus beta, which is what? Say louder. 225 degrees. What is my coordinate point? What is the sign? Yeah, negative, negative. Good. So cos 225 is negative root 2 over 2. Sine 225 is also negative 2 over 2. What will tan be? Positive or negative? Good. Okay, and then lastly, we're looking at quadrant number 4. Beta is 45 degrees. Our theta will be, what's the math for it? 360 what? Minus beta. And that's 315 degrees. What will my sign of my coordinate point be? Tell me the signs. Positive and then negative. Okay, so cos 135 root 2 over 2, sine 135 negative root 2 over 2, tan 135 is what? Negative 1. Okay, why did I make us do that? Because I want us to notice some patterns here. So the first pattern that I want you to see is something that we already know, which is quadrant number 1, the signs are positive, positive. Quadrant 2, negative, positive. Quadrant 3, negative, negative. Quadrant 4, positive, negative. Okay? Now, The next thing I want you to notice, and just look up here for one moment, quadrant number 1, all 3 of the ratios are positive. Quadrant number 2, who's positive? No, who's positive? Just sign. Quadrant number 3, who's positive? Just tan. Quadrant number 4, who's positive? Okay, so we need to know this. It's so important that there's a rule named after it, and it's called the CAST rule. I actually don't like that it's called the CAST rule, and I'm going to show you why. So first of all, in quadrant number 1, all are positive. Quadrant number 2, sign is positive. Quadrant number 3, tan is positive. Quadrant number 4, cos is positive. So it's called the CAST rule because we say C-A-S-T for CAST, but it's kind of confusing because this is quadrant number 4. So it's kind of strange that we're thinking of the word CAST because we never count 4, 1, 2, 3. That doesn't make sense. So the rule is actually starting with all, and it should be called the ASK rule, but that's a hard word to say. So maybe, and this is something that every year I ask my students, instead of calling it the CAST rule, if you want, you can think of an acronym for ASTC. So I think in the past students have said, all students take calculus. That's one that I've heard. All students take calculus. Can you think of another acronym that's easy to remember? All sine tan cos. But that might be hard because then you might mix it up. So what other one can you think of? Or you can just say the CAST rule and just remember that A has to be in quadrant number 1 because it's all.
Angle, cosine, tangent.
Yeah, well, that's the actual name of the words. That might be hard because you're going to mix it up. Okay, so you can either remember CAST, but know that A has to go in quadrant number 1, or you can think of your own acronym like all students take calculus. It's up to you. Okay? All right, flip the page, please. Okay, so using what you know of the reference angles, you are going to fill out this chart, and this is meant for practice. Okay? You're not going to do it this moment. Okay, so as part of your homework for this weekend, you're going to fill out this chart. You're going to practice with the unit circle. Do you have all these answers already? Yes, they're on your unit circle. So you're going to insert them to practice. This is much of the same. You're going to insert this to practice. Okay, I'm going to skip right down to example 5, and I'm going to practice a little bit more of rationalizing the denominator with you, okay, before we finish. We're skipping all the way to example 5. But the rest of this you're going to do for homework. So you're doing example 3 and example 4 for homework. Okay? All right. So I'm on example 5. And remember how yesterday we rationalized the denominator here? What did I multiply 1 over root 2 by? Over? Good. And why am I allowed to multiply 1 over root 2 by something? Abdul Basit? Because it is not just basically, it is 1, right? Anything divided by itself is equal to 1. So we're allowed to multiply anything by 1 because it actually doesn't change the value. But in this case, it will change the appearance. So this will end up being root 2 over, what's root 2 times root 2? 2. Whoever said 1, I'm nervous. Okay? So 1 over root 5, how would I rationalize this denominator? Arshan, what do I do? Good. So it becomes root 5 over 5.
Good morning, Davis. Welcome, students. Today is Friday.
So I did a few more examples of this, guys, in 1.4, but just as a reminder, when you're trying to rationalize the denominator and you have two terms, you're going to rationalize the denominator by multiplying by the conjugate. So those of you who joined my class halfway through, you might not have seen this in 1.4. Did you or no? Okay, so this might be new for you. So this is the conjugate. It is basically the same as the denominator, but you use subtraction. And the reason why you do that is because in the denominator, when you multiply root 2 times root 2, you get a whole number. When you multiply 3 root 2 minus 3 root 2, this becomes 0. And then 3 times 3 is 9. Okay, so the bell just rang. So guys, make sure that you know how to do this as well, please.